Hello Year 5, welcome to your Science Morning. Today we're going to look at how we can separate mixtures. Let's start off with some total recall. In your books, I'd like you to write the titles solid, liquid and gas, and underneath draw the particle diagrams. Then I'd like you to draw the particle diagram that shows a pure metal and an alloy, or an alloy, you can choose as long as you label it correctly, and the particle diagram that shows an impure gas. Pause the screen and have a go at your total recall. Well done if you drew your particles for a solid in nice orderly rows and columns. Solid particles are tightly packed together in order and they vibrate. Liquid particles have a bit more movement, they're a bit more random, but they are touching. And gas particles are completely free and can bounce all over the place. So well done if you got those ones correct. So the diagrams that show pure metals are the one on the left and the one in the middle, because they only have one type of metal, one type of particle in them, where the alloy is a mixture of two or more types of metal. So you can see there that you've got two different types of particles, and that's an alloy. And then we've got the diagram that shows an impure gas. Well, we know that a pure gas would mean that the particles are all the same, so it's only made up of one type of gas. But actually, the impure gas means it's got one or more types of particles in it. So the one with the black particle as well as the white particles in that diagram show that it's an impure gas. Okay, first of all, we're going to start off thinking about how we would separate solids. So how could you separate a mixture of solids? Quite easily, if you're going to be separating sweets or Lego, you can just use your hands, can't you? But what if the solid particles were so small that you couldn't just pick them out with your hands? So how could we separate two similar solids? Iron filings and sand. They're both small particles. You couldn't pick out the sand. You couldn't pick out the iron filings. I'm going to show you a little video now of me demonstrating how we can separate sand from iron filings.
This is my pure iron filings. This is my pure sand. They're both solids, but they're very small particles, which means if we had a mixture of solids, say marbles and Lego, we could just use our hands and pick out the solids. But these particles are so small that I couldn't do that. I'm about to mix these solids together, so I'm going to add the sand to the iron filings. Give it a good mix around. Make sure all the particles are mixed together. Now, because the iron filings contain iron, that means that they're magnetic. So I should be able to use my magnet, just my fridge magnet, to separate the sand from the iron particles, the iron filings. Okay, let's see. I'm going to start moving the magnet around the bottom. It's obviously collecting something, isn't it? Now, a little strategy I could use once I've gone round it all, see if there's any more. I'm just going to tip it all to one side, see if I can shake away a little bit. Are there any more iron filings? I think I can see some. Leave that bit over there, see if there's any more in here. We can see those iron filings going over towards the magnet. Again, give it a bit of a shake off. So this is a way of separating two solids. So if the solid contains iron, you'd be able to use a magnet. Just shake it off a bit. It should be able to show you that we've separated the iron from the sand.
Just to let you know, Year 5, the iron filings are just little fragments of iron. And metals that contain iron are magnetic. So in this little GIF here, you can see that the person's got a magnet underneath and it's making the iron filings move. Didn't actually have any iron filings, so I decided to actually make some myself. So I got a bit of metal that I knew was magnetic and it had iron in it, and I filed it down and filed it down. Okay, in your book, I'd like you to draw the sand particles and the iron mixture, so the particles, and then I'd like you to draw the pure sand and the pure iron filings. So pause the screen and draw those particle diagrams, please. Well done if you drew the particles for the sand and the iron and you mix them together. So you've got some coloured in and some plain, and actually you should only have two types of particles in there because it only had sand and iron. So your sand particles will look like this. So it's a solid as well, isn't it? So it's really important that we keep them in ordered rows touching, and then your iron filings like this. It's okay if you've done a different colour as long as you've done the same colour in each picture. Well done if you got the particle pictures right. Okay, let's just pause and have a recap. I want you to have a go at these questions in your book. I'm going to read them out to you and then pause the screen and have a go at the answers. Why was the mixture of sand and iron impure? Why was the sand sample at the end pure? Why could we use a magnet to separate sand and iron? So pause the screen and have a go at those questions, please. And I'll go through the answers. So the mixture of sand and iron contain two different types of substance, and the pure substance can only contain one. So we know that it contained two, so it was impure. The sand sample at the end was pure because it only contained sand particles and the iron particles had been removed. A magnet can be used to separate the iron and the sand because iron is magnetic but sand is not. Okay, let's have a look at separating a solid and a liquid now. How could you separate a mixture of a solid and a liquid? I'd like you to pause the screen and have a think about if you had water and pasta, how you could separate those, and then about if you had water and sand. Think about that while I load the next experiment.
We're now going to look at separating a liquid from a solid. So my liquid is my water and my solid is pasta. So I'm going to mix these two things together to make a mixture. And then we're going to use a sieve to separate these two items. Now, because the pasta is quite large, it will get caught in the sieve, and that will be how we separate these two things. In a minute, I'm going to show you how we can separate a solid and a liquid if the particles in the solid were too small and would fall through a sieve. So I've given my mixture a good mix, and now I'm going to separate them. I'm going to pour my pasta through my mixture, through the sieve, and then I am left with my pasta in the sieve and the water in the cup. So I have successfully separated a solid from a liquid. Okay, but what if my solid is so small it would fall through the sieve? Here I've got some sand and water that I've mixed together, and I'm going to use a process for separation called filtration. And for filtration you need a filter. Now, a funnel. I've made my own funnel today, so you can make your own funnel using a plastic bottle. You just chop the top off, or you could chop the top off a milk carton, or you could simply make a cone shape using paper. Okay, so this is my makeshift funnel, and I need some filter paper too. Now, I don't have any filter paper. I do have a leftover Merry Christmas napkin that I'm going to use. I'm going to open it up. You might want to use some kitchen roll or toilet paper might work, or tissue paper maybe. I think kitchen roll might be good. Don't put too many layers, because I practiced this earlier and it took ages to filter through. Okay, so I've got my funnel. I need something for my funnel to fall into. Let's get my cup. Because now my funnel should fit quite nicely on top of my cup there. Okay, now I can pour my mixture, my sand and my water, through the napkin, which is my filter paper, into my funnel, which will then allow the water to pour through, to pass through, and hopefully it will collect the sand in the napkin. Let's pour my mixture in. So it's dripping through, that's great. If you have too much liquid in this experiment, then it will take a while to filter through, which is fine for you because you can sit and wait and watch it, but a bit boring on a video. So I haven't used much liquid in mine to try and show you. See if I can show you it dripping through. You see it dripping through there? You can see the water moving, can't you? See that we've just got a bit of water left there, but it's left the particles of sand, and that's because the particles of sand are too big to pass through my napkin, but they would be too small to pass through my sieve. Okay, so when you're making mixtures, you need to think about the size of your particles and which process is going to be best to separate the mixture back into all the pure particles. I think we're nearly there. A little bit more water. I think that looks good. So if I now pull out my napkin, you can see that we've got the sand, pure sand back, and in my cup I've got the water back. Okay, so I've successfully separated two solids there with different methods. One using a sieve, or you could use a colander, I suppose, and one using my own homemade funnel and filter paper.
Okay, let's just recap. So, separating a solid from a liquid. Why was the mixture of sand and water impure? So think about your answer to that one. Why could pasta be removed from the water using a sieve? Why could sand not be removed from the water using a sieve? Why was filter paper better for removing sand from water? And why was the sieve better for removing pasta from the water? I'd like you to pause the screen and have a go at answering those questions in your book, please. Okay, let's go through the answers. The mixture of sand and water was impure because it contained two different types of substance. The pasta could be removed from the water using the sieve because the pasta was too big to fit through the holes in the sieve. Sand could not be removed from the water using the sieve because it was small enough to fit through the holes in the sieve. Filter paper was better for removing sand because the sand could not fit through the holes in the filter paper. Napkin in our case. The sieve was better for removing the pasta from the water because the water could pass through easier. Well done if you got those answers correct. Okay, let's have a look at our next experiment. Now it's really important that with this experiment you have an adult with you if you want to have a go at doing it. At the end of the video, there is an experiment for you to have a go at, but if you're going to try this method, then you definitely need an adult. So, separating and a dissolved solid and a liquid. So this time your solid is going to be able to dissolve in your liquid. So it's not going to be able to go through filter paper because the liquid would just go all the way through the filter paper. It wouldn't hold back the solid. A solution is a mixture where the solid dissolves in the liquid. If something dissolves, we call it dissolvable, soluble. Okay, so the solution is what we call it when a solid is dissolved into a liquid, and that solid is called soluble because it dissolves. So how can we separate a solid if it has dissolved? Next video.
But how do we separate a solid, like salt, if it dissolves in a liquid? Let me add some salt to my water. When a solid dissolves in a liquid, it makes a solution, not a mixture anymore, it makes a solution. And we know that something's dissolved in a liquid when we can't actually see it anymore, and you can't feel it with your spoon, okay? So it just looks like water. Now, a way of separating the salt and the liquid is to heat the salt. So as you can see over here in my pan, I have been heating my liquid, my solution, so that the water evaporates. This process is called evaporation. And if I put my metal spoon above the steam, you would see that it condensates again on the spoon because the heat, the steam hits the cold spoon and turns back into water, which is what's happened on my spoon here. I've got a water droplet. So we could also get the water back if we wanted to. But I have heated the water so that it evaporates, and this process is called evaporation. And left in the middle of my pan, which I look like I've ruined, is salt. So you can see here that this is all the salt left in the pan. So we've managed to separate the salt water solution by using a process called evaporation, which allows us to separate a solid if it dissolves in a liquid.
You don't need to worry about my pan. Obviously, salt dissolves, so it just dissolved when I washed it again. Okay, so we've looked at some different methods of how to separate mixtures. We've looked at using a magnet. So if the item contains iron, you could use a magnet. We've looked at using filtration, either through a funnel with a filter paper or just using a sieve or a colander or something to catch those particles, depending on the size of them. And now we've looked at evaporation, which is heating the liquid to leave the soluble particles. So again, pause the screen and have a go at these questions. Why was the mixture of salt and water impure? Why could we not use filtration to separate the salt and water? And why could we use evaporation to separate the salt and water? Write your answers in your book, please. Okay, let's go through the answers. The mixture of salt and water was impure because it contained two different substances. Filtration could not be used to separate salt and water because when the salt particles dissolve, they are small enough to fit through the holes in the filter paper. Evaporation could be used to separate salt and water because salt has a much higher boiling point than water, so the water evaporates, leaving the salt behind. If you said that the water evaporates, leaving the salt behind, you can have a tick for that one. Oh. Okay, it's time for you to have a go at an experiment now. If you want to use evaporation, I must tell you that you have to have an adult with you. So it says children must have adult supervision. And it's really important that you speak to an adult in your house and check that they're happy for you to use different things. I would be so angry with my children if they just started grabbing things and making a mixture. So make sure you talk to an adult in your house and get permission before you carry out this experiment. If you don't have any of these things and you can't do the experiment yourself, do not worry, because I've got another video that you can have a look at and have a go at. So in a minute, you're going to create your own mixture. This can include anything that your parents and carers are happy for you to use. For example, you could have water, salt, pasta, sand, maybe some mud, maybe some paper clips or something that contains iron, so that you could have a go. If you've got a fridge magnet, you can have a go at using that. Use the processes you've seen today to separate the mixture back into their pure substances. So have a think about how you're going to make your mixture and then how you're going to try and get everything back into its pure state. I'm going to show you a video now of me demonstrating this, and if you are not able to do this for yourself, I'll tell you what your task is.
It's time for you to make your own mixture and work out how you can separate all the ingredients, all the things in your mixture back into their pure states. So I've made a mixture that is made up of red lentils, salt, water and sand. And this is my mixture. I'm just going to give it a good shake up. Okay, this is the mixture I've made. Now you can make any mixture you want at home. Okay, whatever your parents are happy for you to do. But it's really important that if you're going to try the evaporation process, that you have an adult to help you. Okay? If you can't do the experiment at home, that's absolutely fine. In your books, I'd like you to draw this diagram. So this is a diagram of my mixture that I've just made. And I've labelled my diagram. So here it says salt water solution, sand and lentils. Once you've drawn this diagram, I'd then like you to write down the processes you would do to separate my mixture and get them all back in their pure states. So that's your challenge today. Like I say, if you have got the equipment at home, have a go at making your own mixture and see if you can separate them all down.
Once you've completed that, Year 5, I've got a few questions for you just to summarise the day. So if you pause the video here and have a fun exploring and playing with your mixture and see if you can work out how to separate it down. In your books, you can do like I did in the video, draw the picture and write down how you did it. Then I've got a few questions for you. Okay, how can we separate our sugar and water? So have a think, which one? Would you use a magnet for sugar? Would you use a sieve for sugar? Would you use filter paper? Or would you use evaporation? Sugar is soluble. It dissolves in water, so it would create a solution and you would have to use evaporation. Well done if you got that right. How can we separate our iron and wood chips? Could you use a magnet? Could you use a sieve? Could you use filter paper, or would you use evaporation? Well done if you said you use a magnet. Obviously iron contains iron, so it's magnetic, and you'd be able to use a magnet to remove the iron from the wood chips and separate the two items. How can we separate our pebbles and water? What would you use? A magnet, a sieve, filter paper, or evaporation? Well, I know that pebbles or water, neither of them are magnetic. I know that the pebbles are not soluble. They're not going to dissolve in the solution. I know that filter paper would work because I could pour the water and the pebbles and the water would go through the filter paper. However, I know that the pebbles won't go through a sieve, so it'd be much quicker. I could use a sieve like I used a sieve to separate the pasta earlier. Well done today, Year 5. I'm really impressed. There's a lot of vocabulary in there and it's great to see your work. So remember to keep sharing your work with us. I saw this quote and I thought I've got to share it with you just to finish off the lesson today. So it says, science and everyday life cannot and should not be separated. And it made me laugh because today's lesson is all about separation, isn't it? But what does Rosalind Franklin actually mean when she says that? Science and everyday life cannot and should not be separated. It basically means that science is everywhere in everything we do. So think like scientists and start looking around at all the science that is involved in your life without you even knowing. Okay, she was a British scientist and she was best known for her contributions to the discovery of molecular structure of DNA. So that's what makes us up, our DNA. Franklin also contributed to new insight on the structure of viruses, quite topical at the minute. Because she was a woman, her contributions to science were not celebrated as they should have been. So let's acknowledge them today. Just a nice way to end the lesson, a little bit of collective worship there for us to all think about the science that's in our everyday lives and appreciate everybody's successes, no matter who they are. Have a great day, and I look forward to seeing all of your work. Bye.